Hello class, let us look at these examples, these figures here. These are called quadrilaterals. Since they have 4 sides each, so we can define quadrilaterals as polygons having 4 sides. They are called quadrilaterals. Let us take this line AB, BC, CD and DA. This is nothing but a quadrilaterals. So AB, BC, CD, DA, they are the sides of a quadrilateral, meaning quadrilaterals, they have 4 sides. Likewise, we have A, B, C and D. These are called the angles of quadrilaterals. So there are 4 angles for each quadrilateral. Let us take this A, B, C and D. These are called the vertices of quadrilaterals. So the number of vertices are also 4 in a quadrilateral. Let us take the same quadrilateral A, B, C and D. Angle A and angle C, angle B and angle D, they are called the opposite angles. So there are 2 opposite angles each in a quadrilateral. Angle A and angle C, angle B and angle D. When they join A and C and B and D, they form straight lines. These are called the diagonals, and there are 2 diagonals in a quadrilateral. So AC and BD, they are the diagonals of a quadrilateral AB. Now let us have a look at the properties of parallelograms. These are also quadrilaterals, but they have special properties. Let us take this A, B, C and D. Whenever we write, we have to write them in sequence, like we have A, B, C and D. We cannot jumble the words here. Now AD and BC, these are called the opposite sides, and DC and AB, these are also the other opposite sides. So in a parallelogram, the opposite sides are always equal. So we can write them as AD equals to BC and AB equals to CD. These are equal to one another. Let us look at another property. We have this arrowhead which is on line AD and BC. We have 2 arrowheads on DC and AB. These arrowheads represent parallel lines. So the second property of parallelogram, that the opposite sides are parallel also. So we have AD parallel to BC and AB parallel to CD. Next property, we have angle A, we have angle C, and we have angle B, and we have angle D. These are the opposite angles to each other, and in a parallelogram, the opposite angles are always equal. So we can write them as angle A equals to angle C and angle B equals to angle D. Now when you join AC, it becomes a diagonal. We have BD, another diagonal. They are intersecting each other at O. Whenever they intersect, they always bisect each other. So we can write AO equals to CO and BO equals to DO. So they are bisecting each other, meaning diagonals of parallelogram always bisect each other. Let us have a look at the property of a rectangle, which is also a parallelogram. It also has 4 sides. We are taking rectangle A, B, C and D. We have AB, DC, BC and AD, which are parallel to each other, and AB, CD, AD and BC, which are equal to one another. So we can write opposite sides of a rectangle are equal to one another and they are also parallel. So we can write AD equals to BC, AB equals to CD, and AD is parallel to BC and AB is parallel to CD. We have angle A, angle B, angle C, and angle D. The square box represents 90 degree, so we can say all angles are 90 degree each. So each angle, they are equal to one another. So we can write angle E equals to angle B equals to angle C equals to angle D, which equals to 90 degree. BD is one of the diagonals, AC is another diagonal, and these diagonals are equal to one another. So in a rectangle, the diagonals are equal. So AC equals to BD. As in a parallelogram, the diagonals bisect each other. So diagonals of a rectangle also bisect each other. So AO equals to CO and BO equals to DO. Let us consider a square ABCD, which is also a parallelogram. AD is parallel to BC and CD is parallel to AB. So we can write this. Likewise, all the sides in a square are equal. So AB equals to BC equals to CD equals to DA. Here each angle is of 90 degree measurement. So all the angles are equal to one another. That is of 90 degree each. AC is a diagonal and BD is a diagonal. They intersect each other at O. And the diagonals are equal for a square. So AC equals to BD. And these diagonals, they bisect each other at 90 degree. So diagonals of a square bisect each other at 90 degree. We can call them perpendicular bisector. And we can write them AO equals to CO, DO equals to BO, angle AOD, angle AOB, angle BOC, and angle COD equals to 90 degree each. Let us look at the last type of parallelogram, that is a rhombus. ABCD. In a rhombus also, opposite sides are parallel to each other. So AB parallel to CD and BC is parallel to AD. It's like a square, so all the sides are equal. So AB equals to BC equals to CD equals to DA. Angle A and angle C, angle B and angle D, they are opposite angles and they are equal to one another. They are not of 90 degree, so it's not a square, it's a rhombus. The diagonals, they are not equal, but then they bisect each other at 90 degree like in a square. So diagonals of a rhombus, they bisect each other at 90 degree. So AO equals to CO, BO equals to DO, and the angles are 90 degree each. So these are the properties of different types of parallelograms. Depending on the properties of parallelograms, let's try to solve some questions which will help you to solve other questions as well. The question reads, consider the following parallelograms. Find the value of unknown x, y, and z. Let us look at this figure, ABCD, which is a parallelogram in figure 1, and the figure 2 also is a parallelogram where we are supposed to find out the value for x, y, and z. Let us consider the first figure first. So A, B, C, and D, we have angle A as z, angle B as 100 degree, angle C as x, angle D as y. We'll try to use the properties of parallelogram to solve this. So we know that opposite angles of parallelogram are equal to one another So we can write y equals to 100 degree because angle B and angle D, they are the opposite angles, therefore they should be equal. So the value for y is 100 degree. We also know that adjacent angles of a parallelogram are equal to 180 degree when we add them together. So we can write y plus z equals to 180 degree. We can call them co-interior angles or adjacent angles as well. And we already know the value of y as 100 degree. So we replace the value of y as 100 degree in this equation and we get the new equation as 100 degree plus z equals to 180 degree. Now we need to take 100 degree towards the right hand side, leaving z in the left hand side. So our new equation becomes z equals to 180 minus 100 degree, which is equals to 80 degree, meaning the value for z is 80 degree. Now again, angle A and angle C, they are the opposite angles of a parallelogram, which says that they must be equal to one another, meaning x and z, they are equal. So z we already know it's 80 degree, therefore x should also be 80 degree. So we found out the value for x, y and z. Let us consider the second figure here. We know the opposite sides of parallelogram are parallel to each other. So x plus 50 degrees should be equals to 180 degree because they are co-interior or adjacent angles. We take 50 degree towards the right hand side. So x equals to 180 degree minus 50 degree. So x equals to 130 degree. The opposite angles of parallelogram are equal to one another, meaning x and y, they are opposite angles, they should be equal. So y equals to x, they are the opposite angles, therefore the value of y should be 130 degree because x is also 130 degree. Now whenever there are parallel lines, we have corresponding angles which are equal to one another. So z equals to x, which are called the corresponding angles. You have already learned about this in the junior classes. So we know x is equals to 130 degree, so z also should be equals to 130 degree. So we found out the value of x, y and z. Let us look at another question here. The measurement of two adjacent angles of a parallelogram are in the ratio 3:2. Find the measure of each of the angles of the parallelogram. We don't have a figure, so let's draw the figure. A, B, C and D. A, B or A, D, they are called the adjacent angles. Likewise, CB, CD, they are also called the adjacent angles. Likewise, we have BC, BA, DA, DC, they are all the adjacent angles. We can take any one of them. So we are considering angle A and angle B to be the adjacent angle. Therefore, we can write angle A is to angle B equals to 3:2. We have two methods of solving this. So we'll try first method. We need to take out the sum of the ratio, that is 3 plus 2 equals to 5. The formula goes like this. Measurement of an angle is equals to ratio of the angle divided by sum of the ratio into 180 degree, because we know that angle A and B, they are adjacent angle and they should be equals to 180 degree. So let's find out the value for angle A. So we can write angle A equals to 3 by 5 into 180 degree, where 3 is the ratio of angle A, 5 is the total ratio into total angle. 5 times 1 is 5 and 5 times 36 is 180. So angle A equals to 3 into 36 degree. Therefore, angle A equals to 108 degree. Likewise, for angle B, 2 by 5 into 180 degree, where 2 is the ratio of angle B, 5 is the total ratio and 180 degree is the total angle. Likewise, 5 1 is 5 536 is 180. So we have angle B equals to 2 into 36 degree. Therefore, angle B equals to 72 degree. But we have been asked to find out all the angles, and we can use the property of parallelogram that opposite angles of parallelogram are equal. Therefore, angle A equals to angle C, which is equals to 108 degree. Angle B equals to angle D, which is also equals to 70 degree. Therefore, we found out all the four angles of the parallelogram by this method. Let us have a look at the second method now. Whenever we are doing this method, we have to assume a ratio, a common ratio, let us say x. So we can write angle A is 3x and angle B as 2x. We know that they are the adjacent angles, and when we add them it becomes 180 degree. So angle A plus angle B equals to 180 degree. We know angle A is 3x, angle B is 2x. So 3x plus 2x equals to 180 degree, and 3x plus 2x is 5x, which is equals to 180 degree. Now 5 divides 180 degree. So x equals to 180 degree by 5. 5 times 1 is 5. 5 times 36 is 180 degree. Therefore, we are getting the value for x as 36 degree. We are not done here. We need to find out angle A, and we know that angle A equals to 3x. So angle A equals to 3 into 36 degree, and 3 times 36 is 108 degree. Angle B equals to 2x. So 2 into 36 degree. Therefore, angle B equals to 72 degree. Again, we'll be using the property of a parallelogram that opposite angles of parallelogram are equal to one another. Therefore, angle A equals to C equals to 180 degree. Angle B equals to angle D equals to 72 degree. Therefore, we found out all the four angles of the quadrilateral, that is a parallelogram. Question 3. The figure here, we need to find out the angle measuring x, y, and z. So this is the figure. We'll solve them slowly. We have 40 and z, we have 70. These are called the corresponding angles, and as we know, they are equal to one another. That is, corresponding angles are equal to one another for two parallel lines. Therefore, we can write corresponding angles are equal. So z plus 40 is equals to 70 degree. We take 40 towards the right hand side and we subtract from 70, so z equals to 30 degree. We found out z now. We know that adjacent angles, when we add, this become 180 degree. So we'll take adjacent angle x plus 40 degree plus z equals to 180 degree. We know the value of z as 30 degree. So x plus 40 degree plus 30 degree equals to 180 degree, and 40 plus 30 is 70. So x plus 70 is equals to 180. We take 70 towards the right hand side. So x equals to 180 minus 70, and 180 minus 70 is 110. So we found out x to be 110 degree. Now, before going to the next step to find out the value of y, we'll try to understand this figure. It looks like n, or if you rotate this, this looks like z also. Whenever we have such figure where we have 40 here and we have y here, this 40 and y, they are called the alternate interior angles, and these angles, whenever there are two parallel lines, then these angles are equal to one another. So alternate interior angles are equal. Therefore, y equals to 40 degree. Therefore, we found out the value of x, y, and z. Let us have a look at this figure where we have the quadrilateral or the parallelogram RUNS with the diagonals with some figures there. So we need to find out the value of x and y for this figure. If we connect those diagonals and we put mark O in the center of the diagonals, or the intersecting point of the diagonal, we get RO, ON, OU and OS. Since this is a parallelogram, so we can easily see that diagonals are parallelogram, they bisect each other, so we can use that property to solve this figure. So when we consider the diagonals, UO is equals to OS, NO equals to OR. So we'll be solving the first one. Here UO is equals to OS and NO equals to OR. These are equal to one another because they bisect each other. So taking UO equals to SO, we have UO as y plus 7 and SO as 20. We take 7 towards the right hand side and subtract from 20. So y equals to 13 units. Likewise, NO equals to OR, and NO is x plus y and OR is 16. We have the value for y is 13 units. So x plus 13 equals to 16, and we take 13 towards the right hand side and subtract from 16, so we get x equals to 3 units. So we have the value for x and y for this figure. Let's consider the last question, which reads as: in the given figure, RISK and CLUE are two parallelograms. Find the value of x. The figure is like this: RISK, which is a parallelogram, CLUE, another parallelogram, where this is the point x, angle L is 70 degree, angle K is 120 degree. To find out the value of x, we'll have to solve this by separating the parallelograms. So we'll consider the parallelogram RISK, where K is 120 degree. Angle K and angle S, they are adjacent angles, so they should be equal to 180 degree in the parallelogram RISK. And angle K measures 120 degree, so 120 degree plus angle S is equals to 180 degree. We take 120 degree towards the right hand side and subtract from 180 degree to give us the value of angle S as 60 degree. We'll consider the second parallelogram CLUE, where L equals to 70 degree. We very well know in a parallelogram opposite angles are equal, and L and E, they are opposite angles of parallelogram, so they should be equal to one another, and angle L is 70 degree, so angle E should also be equals to 70 degree. But we are not done yet. We are supposed to find out the value of x. So let's reconsider the figure that was given to us in the beginning. After removing some of the portions from this figure, we get this figure, which is a triangle, and we very well know that angle sum property of a triangle is equal to 180 degree. So angle E plus angle S plus x equals to 180 degree. Angle E measures 70 degree, angle S measures 60 degree. So replacing those with their values, we have 70 plus 60 plus x equals to 180 degree. So 70 plus 60 is 130 degree plus x equals to 180 degree. We take 130 towards the right hand side and x equals to 180 minus 130 degree, and we know 180 minus 130 is 50 degree, so the value of x is 50 degree. So this is how we can use the properties of parallelogram to solve questions related to them. Thank you for watching this video. Hope you understood the concept behind properties of parallelogram.